of our design and existing CO sensors is comparable to that of a chunky 1980s block cell phone and an iPhone S. We faced two design challenges. First, we became unable to grow carbon nanotubes due to the deposition machine going out of service. Another challenge we encountered was finding that our plastic sample would not stabilize, but it was due to strain. Contrary to our challenges, we were successful in discovering that our glass sample had stabilized resistance of approximately 830 ohms. After finding the sample resistance, it was clear we would measure voltage across a series shunt resistor. We were also successful in uncovering the variables of our sample: temperature, light, stress and strain, and humidity. In the future, we will calibrate our system by control and validation. We'll control the plastic box using calibration gas, and we'll validate our results using a Draeger CO sensor. How do we do it? With a motivated team, of course. I was team leader, and I took charge of all communications, and Ryan Calloway grew our samples in the internal building. Derek Easterling researched resistance detection methods. Tim Stamps conducted alerts research, and David Shin researched the testing enclosure. I will conclude by reinvigorating your memory of our carbon monoxide carbon nanotube sensor. Our design miniaturizes existing CO concepts. We will measure voltage across a series shunt resistor, and in the future we will calibrate our system with control and validation. But most importantly, we are designing peace of mind. Thank you. We'll take questions now, but please visit our poster.
Right. Is there any question for this program?
Yes.
What other gases is it sensitive to?
It would be sensitive to any other gas that has carbon in it, but for this project, we are sticking in scope with carbon monoxide.
So how do you know if it's measuring carbon monoxide or carbon dioxide?
Good question. For this one, we're going to just calibrate it using the CO gas, and I know that's going to be another challenge we're going to face next semester, and I'm sure we'll try to isolate that when it comes into our project. Yes.
How does the sample gas enter your enclosure?
Okay, great. For the testing methods, we're going to be using a calibration gas, which is a canned gas of carbon monoxide. And we have a box, we're going to put it inserted through a tube, so it's going to go into a tube and it'll gas up a box.
Is there any benefit of using carbon nanotubes? Like, why did you decide to use them?
I like that question. The reason why we use that carbon nanotubes is to miniaturize it as small as possible. If you go to the store right now, you look at the carbon sensors, and they're probably about like this big, and you can plug it into the wall, or it's using batteries. But we want to make it so small where we can have like a plug-in into the phone, where you can take the sensor with you anywhere to keep you and your family